We've had lots of practice with these first 5 problems, so this key does not include the solutions to those problems. Let's jump down to the next grouping, 6 to 13. On these, you get to have a choice between factoring, square root method, and quadratic formula. The focus of this entire key is on quadratics. And so the question is, which one are you always going to try first? And my recommendation is always factor if you can. And to factor means that you've got to move terms over to one side so that you've got it equal, some function equal to 0, and then do your factoring from there. It's only when you can factor that you're going to use the quadratic formula. Now sometimes things are already factored, or they look like you could use the square root method, such as 10, where you have perfect squares on both sides. And so in that one, we're going to see that you would just take the square root of both sides. So go ahead and take a look at number 6. You can see that you can bring the 13x over, go ahead and factor it, use the 0 property. Yes, you actually have to set them each equal to 0. Don't forget this guy. The only reason you're allowed to use the 0 property is because this equation is equal to 0. And then solve each of those pieces to get those solutions. Now when you look at number 7, you see that this one is actually solved 2 ways. You can add the 144 to both sides to get x squared equals 144. Use the square root method by taking the square root of both sides and get those 2 solutions. Of course, you could factor it as the difference of 2 squares and move on from there. The rest of these are very similar to that, and so feel free to look through the rest of these solutions. I'll move it around so you can pause the video when you want to look at a particular one, 10, 11, and then 12, 13. What you're seeing here, this one has to have the quadratic formula. I recommend that you write down the work on the side, then put that value inside the square root. Don't forget to write it as 2 solutions. So let's look at 14. 14 is giving you this particular quadratic and asking you to describe some characteristics of the quadratic in the plane. And so don't forget to show your work for finding the vertex. When you're in part E looking for X-intercepts, you're going to set y equal to 0, so then solve that by factoring. You can write these as points or as x equals 0, x equals 5, which is what's here. Just be careful. The online homework system and the gateway exams are not very flexible, so always put it in the form that it's being asked for. And something else to look at, let's look at G, which is the range. We're looking at the y values. We know this parabola faces up, so it faces up. It's got a minimum that occurs at the vertex. That vertex y value is negative 25 over 4, which we found in part B. So the y values are going from that up to infinity, so you include a bracket because it includes that y value, parentheses on the infinity. For number 15, we're given a function. You need to decide if it's got a max or min and find that value. And we know it's a quadratic. The max or min is going to occur at the vertex. For this guy, it's facing up because of the 6. Go ahead and find the x-coordinate of the vertex, substitute it in to find the y-coordinate of the vertex, and then you're done. You just need to give your answer of minimum value of whatever the y is you found. And it occurs when x is equal to that x value. Now be careful, you don't want to round these, and so make sure you have exact answers for those. 16 you're going to see on the next page. It was longer than I had space for. 17, we are asked to find the vertex and then the x-intercept. So just running it through, negative b over 2a again to find that vertex. To find the x-intercepts, set y equal to 0. And we always factor if we can, so we factor and then solve each of those pieces and you're done. For 18, you're given 2 pieces of information. Let me move this up so you can see the whole thing. We're given the perimeter is 26, the area is 40, and we're told it's a rectangle. We know perimeter is add up the sides, so we're going to add up the sides and put them equal to 26, which they gave us. Go ahead and solve this for one of these variables. So I solved it for x and got 13 minus y. Then we're going to substitute that 13 minus y in for the x of the area. The area, remember, is length times width. Length is x and y is width. Or vice versa, it doesn't matter, call them whichever you want. You still multiply them together to get the area. So substitute that in and then go ahead and multiply. Once you do that, you've got a factor to solve it and you get 2 values. and an 8 and a 5, you substitute that back up into x, and you see that you find if you call it 8, you get the 5. If you call it 5, you get the 8. The rectangle is 5 meters by 8 meters. Don't forget those units on there. Let's look at number 16. For this one, we are given this general quadratic standard form that we have to find the a, b, and c for. They tell us the vertex is 1, 3. We know that 1 is negative b over 2a, so set it equal to that. Multiply by negative 2a to get the b. Substitute that b in here for where the b is. So now we've got two terms with a's in it. Now we want to get c to be in terms of a so that we can solve for a and get the first value of that coefficient. To do that, we're going to use the 1, 3 from that vertex. Y is 3, which is f of x. X is 1, so we put a 1 in for each of these x's and then go ahead and solve this for c. Remember, we want it in terms of a, so we can substitute it in, and that is negative a plus c, positive a plus c. So now we've got an expression, move it up so you can see the whole rest of it. We've got an expression here with just a's in it. So if we use the other point, negative 1, negative 8, negative 1 for the x's, negative 8 substitute in for the f of x, which is the y, and then go ahead and solve it for a. If you use 1, 3 again, which is what we used up here, you're going to end up just getting a true equation down here, and the a's will add to 0. So you've got to use the other point. You can't use the same point over and over again. Once you get that a, ugly fraction, who cares? Substitute it back into the b expression to get b. Substitute it back into the c expression to get c. Once you get that, go ahead and put them in to find a, b, and c for your final then function. For number 19, for this guy we have daily revenue given to us. Here's our function for revenue. They give us the cost function, so both of these have been given to us. We're asked how many boxes of candy must the firm sell to maximize revenue. It's a quadratic. We need to maximize revenue, so that means we need the x-coordinate of the vertex. The x, remember, is the number of boxes. R of x is the revenue. So negative b over 2a, a and b have these values from the revenue function, so make sure you're taking them from the correct function. And you get 118.75. You need to round that using your rounding technique, so we get about 119 boxes. But now what you have to do next is find what that maximum revenue is. Yes, this is the x-coordinate of the vertex, but we rounded it to 119, so the max revenue here, when we're looking at that, we're finding the revenue with 119 boxes. Yes, that revenue is going to be off a little bit because it's not at the exact vertex, but because we rounded here, we have to use that 119 here. Profit is given by revenue minus cost. We knew that. Substitute the functions in that you were given. Revenue is this, minus cost, so it's minus, use parentheses here, because what a common error is to distribute that negative over here, and lots of people forget that. So use parentheses, write this line out, then distribute so that you've got the negative signs. So that's our profit function. Now, they're asking you how many boxes do you need to maximize profit? Well, that profit function's a quadratic. It's facing down because of this negative, so we know it has a vertex that is the maximum. So we need to maximize the profit. We need the x-coordinate of the vertex. And we're doing the same thing over and over again. And so pull the a and b off of the profit function, negative b over 2a, and you get this value. Go ahead and round it using rounding skills, about 103 boxes. You want to know what the maximum profit is. Because we rounded it here, we use that number of boxes to actually calculate that profit and get 175.39. And yes, you need to have it in dollars and cents, so round to the nearest penny. Number 20, we've got variable and fixed costs given to us for owning a car. And what are the variable costs? They tell us 25 cents per mile, where X is the number of miles. The fixed cost they give us is $14.59, so that's our function. The next thing they ask us to do, they say Sally drove her car 15,000 miles. What was her cost? Well, X is 15,000, so substitute that in and you get 52.09. For number 21, This one we got to watch units because we're talking kilowatt hours here. And there's 1,000 watt hours in a kilowatt hour. So we're going to do some conversions. They're asking us first if we have a home and it has 20 100-watt light bulbs. They're on for 3.13 hours a day in kilowatt hours. Do the bulbs use how much electricity in kilowatt hours do these bulbs use over the course of an average month? And they're telling you to use 30 days. So they're telling us 3.3 hours per day, 100-watt light bulb, 30 days. The days divide out, so we get watt hours, 9390. We want to convert that to kilowatt hours, which is 9.39. Then how much are you saving? So you have this original amount, how much electricity you use with the 100-watt light bulbs. And instead, you're going to substitute, instead of those 100 watters, you're going to use CFLs of 26 watts. So this is what we would have paid. Let's subtract off what our new bill is, and that difference is going to be how much we are saving in kilowatt hours, how much electricity we're saving. Go ahead and multiply that out. You get watt hours, then change it to kilowatt hours, then subtract these two values to get this is the number of kilowatt hours that you have saved if you do replace those light bulbs. Next, 22 is we're going to have to go back and grab some information from 21, but let's get started first. They tell us that they're going to charge $10.45 a month for our electricity and 9.75 cents per kilowatt hour. $10.45 and then 9.75 cents is $0.0975 in kilowatt hours, so we have the same units. You got to be careful of that. And K is the number of kilowatt hours. For the last month, Frank used 650 kilowatt hours, so you substitute the 650 in, and his bill was $73.83. Just calculate that. For C, now they wanted to swap out those light bulbs as described in the previous problem. How much more money is he going to save on his electric bill? Well, from the previous step in number 21, we learned that he would save 6.9486 kilowatt hours. If it's 0.0975 per kilowatt hour at a cost, just multiply them together, and that tells you how much he's saving, which is about 68 cents. Now, that doesn't sound like very much, and it's going to take a while to pay for those CFL light bulbs. Let's take a look at number 23. For this one, we're talking texts per month and cell phone bill. So the number of texts, the price of the bill, number of texts, price of the bill. We want to have a function for cost. To do that, we need slope. So take the y's over the x's. So I took the second point minus the first, second point minus the first. So the slope is this, and the slope is ugly on this. Do not round this guy. Just leave him like he is. On your graphing calculator, you hit math, and the first item is going to be frac with an arrow next to it. Just hit enter, and it'll turn your decimal into a fraction for you. And enter that here. We now need to get our function or equation, and you can go find the b for the y-intercept, or you can use this equation and substitute in, which is what my favorite way to do it is. And substitute in the x and the y from one of the points, and then your slope goes here. And again, fractions, they're ugly, but leave them as they are. You got to do a last step because they're asking for a linear model phone bill P as a function of T text. Function of T text means T is the independent variable, and that goes in here. P is the phone bill itself. So you got to rename this. Don't forget to rename your variable as well. The next one, they're telling you she sends 1,000 texts. What's her bill? So you just do P of 1,000, substitute it in, get an approximate dollar value. Don't forget to round for the cents. And then find the P intercept. To find the P intercept, you set T equal to 0. So we have P of 0, and that gives you about 140.07. What does that mean? That means when you send 0 texts, remember that's this value here, will cost 140.07. That's the price of the bill. So this is the cell phone bill everybody would want, that the more text you send, the less money you pay. I know, it's a weird example. So let's look at, sorry, move this down, 24. We've got an immunization program, and they're doing awareness campaigns. When 5 million is spent on the awareness campaign. The mortality rate from pertussis is 0.5%. Convert that 0.5% to 0.005, or that percentage is going to get in the way. They also tell us then 10 million will get you a 0.3% mortality rate, so convert that. So here are our 2 points. We're looking for a linear model, so let's find the slope. Take the difference in y's over difference in x's, and you get this. And then go find the y-intercept, or for b, or use this equation to go ahead and substitute in. You got decimals here. Don't be afraid of those. They actually add together and multiply really nicely to get you this equation, y equals this guy. But they are asking for a linear model that has the rate for pertussis, m, is a function of the amount of money spent. So function of, that's telling you then what the independent variable is, which is a, and the a goes inside here. That's like our x. That's the variable that's here, and they're naming the outer function m. Don't worry about whether what's capital and what's small. It doesn't matter. When it says a function of, that's the variable that they're talking about. Now, part B, find the m-intercept. I rewrote a point so that you could take a look at them in the way we do, where we usually say x and y. They want the m-intercept. The m is the rate. Remember, a, amount, is the independent variable. The rate for mortality for pertussis is the y value here. So they want the m-intercept. They want to have this intercept, so we set the other guy equal to 0. So we find then when a is 0, so you're spending no money, what's the mortality rate? Substitute that in, you get 0.007. So when $0 are spent, the mortality rate is 0.7%. Then for the last question, find the a-intercept. Find the a-intercept here means you set the other one equal to 0. So we're going to set m equal to 0, which means y equal to 0. So set your function equal to 0. 0 here equals my function. Solve for the variable that's left, which is a. You get 17.5. Remember, the m equal to 0 is the mortality rate is 0. So when the mortality rate, if you want it to be 0, how much money do you have to spend? That's what you found when you found this guy. So if you spend 17.5 million, that's the amount of money for the awareness campaign, the mortality rate will be 0%, which was the intercept we were looking for. So that's it. Hope you're having a great day.